Hi everyone, welcome back to my YouTube channel Chemistry with Sumitpramar. Today we'll be solving past paper from year 2018 October-November series, paper code 970111. Let's start with question number 26. Sodium reacts with 1 mole of compound Y to produce 1 mole of hydrogen gas. Which compound could Y be? If I look at option A, which is butanol, if it reacts with sodium, it gives sodium butoxide plus hydrogen gas. If I write down the complete balance reaction, it will be CH3, CH2, CH2, CH2ONA plus half mole of hydrogen gas. Similarly, second one also contains one OH group. This hydrogen will be replaced by sodium, and half mole of hydrogen will be produced. Option C is a carboxylic acid. This is butanoic acid, so it will form sodium butanoate, CH3, CH2, CH2, COONA, and this hydrogen will be replaced by sodium and it will form half mole of hydrogen gas. But if I look at option D contains two functional groups. One is OH functional group and the other one is carboxylic functional group, COOH. That means both these hydrogen will be replaced by sodium. It will react with 2 mole of sodium to form CH3, CHONA, COONA plus 1 molecule of hydrogen gas. That means 1 mole of hydrogen gas will be produced when sodium reacts with this particular molecule. Option D is the correct response. Question number 27. Which compound shows optical isomerism and gives a positive test with alkaline aqueous iodine? We know that a compound shows optical isomerism if it has a chiral center. That means 4 different groups should be attached to the carbon, and it shows alkaline aqueous iodine positive iodoform test if it has a methyl ketone group, CH3CO group, right? Let's look at option A. Option A is CH3, C double bond O, CH, OH and CH3. As we can see that this carbon is attached with 4 different groups. This is different, all of these are different groups. That means this is a chiral center, hence it shows optical isomerism. It also contains a methyl ketone group which can give positive iodoform test. That means it can give positive test with alkaline aqueous iodine, hence option A is the correct response. You can check with other options, they won't show both of these features. Question number 28. Ethanedioic acid is reduced using an excess lithium aluminium hydride. What is the organic product of this reaction? As we know that lithium aluminium hydride is a strong reducing agent which can reduce carboxylic acids into alcohol. So if I take ethanedioic acid, COOH and C double bond OOH in presence of lithium aluminium hydride, it can reduce these 2 carboxylic acid functional groups into alcohols. Hence the product will be CH2OH, CH2OH, and this is ethane 1,2-diol. Hence option B is the correct response. Question number 29. The diester shown can be hydrolyzed by heating with excess aqueous sodium hydroxide. What will be the products? As we know that when esters are hydrolyzed in presence of sodium hydroxide, it gives sodium carboxylate and alcohol. So if I take excess NaOH, we know that this bond will break and ONA will be added on this side and hydrogen on this side. Similarly, here also ONA will be added on this side and hydrogen on this side, and the product that will be formed is HCOONA and then plus OH, CH2, CH2, CH2OH and CH3, COONA. If I look at the options, option C is the correct response. Question number 30. J is a branched chain alcohol, C5H12O. J is heated under reflux with an excess of Cr2O72- H+ until no further reaction occurs. An organic compound K is formed in good yield. The IR spectrum of K is shown. We have to identify what is alcohol J and compound K. As we know that K2Cr2O7 acidified potassium dichromate is a strong oxidizing agent. That means it can oxidize this alcohol. If the alcohol is primary alcohol like RCH2OH, it can be oxidized to carboxylic acid RCOOH. If the alcohol is a secondary alcohol RCHOH, it can be oxidized to ketone RC=OR. If the alcohol is tertiary alcohol, then we know that there won't be any oxidation. Since oxidation is taking place, that means J is not a tertiary alcohol. That means this cannot be an answer. Now let's look at, so that means J is either secondary or primary alcohol. Let's look at the IR spectrum. As we can see that there is a peak at around 3000, and this is a very common peak for any organic compound because it represents CH bond, which is found in almost all organic compounds. There is another peak at around 1700, and we can see the band for this one. It shows that this is for a C double bond O. That means this particular molecule K is a ketone. K is ketone, because if it was carboxylic acid, there should be an OH at a peak at O for OH also. That means at around, if I look at OH, it should be at around 3200 to 36500. Since there is no peak at 3200, that means this is a ketone. Now let's look at the options. Okay, so K is ketone, and that means J must be a secondary alcohol. J is a secondary alcohol. If I look at the options, option A is a primary alcohol, so this cannot be an answer. Similarly, D is a primary alcohol, so this cannot be an answer. A and D cannot be an answer. Let's look at option B and C. Option B is a secondary alcohol, and option C is also a secondary alcohol. These two can be an answers. But let's look at the statement once again. Question number 30 says J is a branched chain alcohol. It is a branched chain alcohol. So if I look at option B is a straight chain alcohol, whereas option C here is a branched chain alcohol. If I draw the structural formula, CH3 CH CH3 CHOH and then CH3. This is a branched chain alcohol, hence option C should be the correct option. Thank you for watching my video. Please like, share and subscribe to my channel, Chemistry with Sumit Pramar.